Without any delay, I'm going to introduce Yong-Lak Park from West Virginia, and he's going to talk about some applications in the field. So you just heard about the developments of robotic technology and things that are going on. Yong-Lak is going to talk about some applications. So, Yong-Lak.
Yeah, I got you. Okay, thanks for organizers, Steve, Jeff, and Ian for inviting me to give this seminar. Okay, the previous presenter, Ken, talked about some development, but I'm kind of in the other opposite side. I'm a user. So I'm a user, but I want to have some technology. So I poke engineers to develop something for me. That's how it works, okay? So the last slide, actually, the Ken showed me was like the guys, like the clip, right? Right? That's actually continuous, my talk, actually. I am going to spray natural enemies, not the pesticide. Okay, so here we go. I'm from West Virginia. Okay, so West Virginia, have you been in West Virginia? It's about 70% is mountain, right? So if something happens in the middle of the mountain, nobody can go there and check it. So like there's a small fire on the mountaintop. Who is going to go there? It'll take about 5 hours to hike up, right? The manned airplane can go there, but again, the fire is so small they cannot see maybe, right? So that's the West Virginia. One of the problem is we don't have a lot of resources, okay? We don't have human resources to do pest control or monitoring. We don't have a human resource for management. So here we go. What happened in West Virginia in general is West Virginia suffered or still suffering from invasive species. So gypsy moth came through, right? And the emerald ash borer has come already from the north. Soybean aphids is coming. You heard about brown marmoset stink bug? They already went through. And a lot of insects are coming from the south because of global warming. So West Virginia suffers so many of these. But if you look at the location of West Virginia, it's very important. It's between Midwest and East Coast, right? Whatever happened in Midwest, the insects or plants or disease, whatever, plant disease or weeds, whatever is coming to the east, more likely they have to go through West Virginia, or vice versa. So West Virginia is quite important. That's why the government agencies, like the Forest Service, USDA, aphids, what they do is this program, EDRR, Early Detection and Rapid Response. Why don't we detect so early enough so that they don't spread, right? And that we control them. To do that, we need the resources, again. For example, West Virginia has about 11, 12 universities. Do you know how many entomologists are there? 2. You are seeing one of them. I have extension entomologist. So my job, okay, a lot of people say, hey, Dr. Park, can you survey West Virginia for emerald ash borer? I want to do that, but I cannot do that. So I had a lot of needs for those things. So the only way I could think at the time was, why don't we use some technologies? How about satellite? How about manned airplanes? How about unmanned airplanes, right? So that I don't have to go. Some machine has to go to do something, right? So that is the idea of my talk. So if we are talking about remote sensing, we are detecting something wrong on the Earth's surface, right? And by using some sensors and whatever. And this is one of the example. This is an NAPP, National Area Photography Program. Okay, every 3 to 5 years, the governments fly over all the surface of the United States, and then they provide image for free. You can get this image for free. This is a near-infrared image. This is a 1 meter resolution, which means anything greater than 1 meter, you can kind of detect it. That's the idea. Okay, this is actually California vineyard. Okay, if you look at this area, you see some problem area, right? And also you can see some cars going around. Right. Again, this is free for everybody. You can download it. You can use it. What's the problem? Image may be outdated. If you want to detect something, you have to wait 3 to 5 years. That does not work for IPM, right? Right? So here we go. You can hire actually commercial pilot to fly over with some sensors or cameras. You can do that. Okay. They provide actually 6-inch resolution. That's actually the minimum, not minimum, yeah, maximum they can go. They can go even down if you pay more. But the problem is, to do this, you need airstrip. If you don't have actually airstrip nearby, you have to pay. I think they have to fly over, come to your site for 2 hours. You have to pay for that. And then the problem is you need a pilot. Some pilot is not easy to work with. Okay, so here we go. And then you need a lot of money sometimes. So let's talk about West Virginia. We have a 70% of mountain. If I'm going to hire somebody who fly over, take a picture, we need millions and millions of dollars to do that. Right, and also the pest problem does not go forever, right? Sometimes it occurs in 1 week. You need to detect it, right? And then you need to do something. If you cannot wait for a month. So one of the problems with using commercial airplane is, one of the problems actually, the most important problem is the safety. Okay, this is a news from Forest Service about 4 or 5 years ago, which says a fatal plane crash while conducting area survey. Oh, in West Virginia. So what is an area survey? So Gypsy Moth came, and then we are talking about 70% of West Virginia, okay? So somebody has to monitor it so that they can give a recommendation for pesticide application with the airplanes. So somebody has to fly over to estimate how much damage we have, right? Think about it again. 70% of West Virginia, they have to fly over in a couple of months, maybe sometimes a month. So they keep flying over and over and over again. Everybody's tired. Pilot is tired. You know, onboard entomologists are tired. What they do is they actually, okay, there's not much technology. They lean and look through the window. Oh, there is a patch, 5-acre patch. Okay, they draw. That's how they do it. Otherwise, they cannot finish in time again. The management decision should be made very early so that, you know, actually the airplane goes and applies the pesticide. So we lost actually 2 entomologists and as well as pilot, and it was very sad. This person was one of my students actually in the class. So anyway, so there's a safety issues. You heard about actually today's morning in the news, like German wings, the airplane crashed in like a French Alps, right? Right, so that happens. Okay, so sometimes, not always, maybe sometimes we need like a very serving like very safely in a large area again. It would be better if it's real time or near real time, right? So that we can make a decision for pest management very quickly. Sometimes we need to acquire high resolution images, which means we need to fly kind of low, right? And then we want to cover large areas, extremely large areas in a short period of time. And then this is another one, as Ken showed you. There are a lot of areas hard to access or hard to reach. Nobody want to go there, do something, right? So all of this can be done by using unmanned aerial vehicles, maybe. That was our initiation of this, motivation of this project. So what is actually UAV? It's unmanned aerial vehicles or unmanned aerial systems, or we call it drone, right? Okay, at West Virginia University, we have an aerospace engineering program, which I co-work with. And we have actually big airplanes like this. Big airplane means you can put more stuff, like a higher payload, right? And we have a jet. This UAV flies about 150 miles per hour. So this may be good for kind of emergency cases, right? And we have a helicopter. So we call the rotary wing, which means it can hover. Hovering is a good thing, right? You can see very detailed for a long time. Problem is you cannot cover maybe really large areas. Also, we have a very small, this is actually the UAVs that I'm going to talk. Very small UAVs. You can backpack it, or sometimes you can disassemble, and put in the backpack, go, and then fly. So that's kind of the UAVs. Okay. Again, I didn't make it. My engineer partner made it. Okay, here we go. All of these, actually, the UAVs can be autonomous. Autonomous means they do by themselves. So basically, surely no onboard pilot, that's UAV, and also no ground pilot even, because we program it to go somewhere and then to do something. So it can be done by, actually, GPS guided, right? So basically what it happens is, go there, take a picture, go there, spray pesticide, and return back. And they may do it, because we programmed it, okay? So here we go. So today's talk, I'm gonna actually introduce what we have been doing for 8 years so far at West Virginia University in terms of precision delivery or precision management of insects, weed, and plant disease. Okay, 2007 and 8, actually we did a pilot study. We want to see how detailed the UAV can see underground, okay? So there was just a small study. And then it worked out, so we went to California to do some weed detection, okay, in vineyard. And then it worked out, so now actually, I'm an entomologist. I want to see insects on the ground using UAV. Is that possible? Right? Challenging, right? And then, okay, by that time, I learned that the UAV industry is already saturated. There are so many engineers that are making small companies and making UAVs. And just detecting something is not enough, actually. So why don't we deliver something? Okay, pesticide, you had the, right, pesticide is so common, so why don't we deliver some good insects to better off the bad ones, like a weed, other insects, like plant disease, whatever, okay? So 2007 and 8, we used actually so we did pilot study. We tried to see what UAV can do. So this is actually one of our earlier model. This is actually MiG-29. That's about 6 feet. This was donated by US Army. Do you know how US Army used this? This is styrofoam based. It's styrofoam, very light. What US Army did was, this is for actually shooting practice. They go and then they shoot it and then make it down. So we got they donated about 7 of them. So this is a styrofoam based, again, very light and very low cost. Okay, but it can hold about 15 pounds. That's 6 feet by 5 feet. And maximum speed is about 60 miles per hour. So why don't we use this? And then what we did was we put the sensor. This is early stage. So we put just camera, Canon level XT camera at the time. It's $400 at the time. Okay, underneath, so that it like faces to the ground. And then we put the data logger, which is we call the black box. So, okay, and then we put GPS on it. So far, our design concept was always cheap, light, and easy. Because as Ken says, whatever we develop the technology, it may take time for commercialization and then for growers to use, right? You said 10 years, right? We didn't like that. Why don't we make it so cheap, light, and easy so everybody can use it? Okay. There are a lot of issues, legal issues, right? We are going to talk about it later. But so anyway, so this was the first picture we took from that UAV. So this was actually a small airstrip, UAV airstrip. So we have actually a flight test facility, believe it or not. So it's for UAV. So here we go. So there are 3 guys up there, right? And can you see what do they do? They're kind of looking up, right? That's a good sign, isn't it? We see humans' behavior from UAV. Okay, three people coming down here, right? And if you zoom in, hey, now they are walking, right? It looks like the left one has you may not see it very well, but it has wearing like a blue hat. And the middle one looks like no hair, kind of bald, right? We see these things. Oh, so this is good. So we took continuous, picture continuously, and we see one car is driving kind of on the road, and then we zoomed in. Okay, it looks like this way. So this, and then we can zoom in one more time, right? We can zoom in whatever we want. This is an image. So this is about 3 meters. And if you're a car expert, you may be able to identify this, right? We cannot see the person inside, but we see, can you see green sticker on the windshield? That's the registration sticker, right? Right. If something bigger than registration sticker, then we may be able to see it or detect it, right? Or if there's a color difference, we may be able to detect it. So there's so many things like that in agriculture, right? Flowers, fruits, right? Some insect damage or plant, disease symptoms, weed. So now actually we got some funding from for that, and then we went to California to see what we can do with this UAV. So we went to California to detect insect feeding, plant disease, Pierce's disease in a vineyard in California, and weed. Okay, we went to the Central Valley. So this is actually the Central Valley at the time. Okay, what you see is these kind of flowers. These are morning glories. This vineyard was heavily infested with morning glories, and growers want to do something. But the problem is this grower owns 2 mile by 2 mile vineyard. There's so many, right? So we offered, why don't we fly over and to see if we can tell how many morning glory flowers you have in that area. Okay, so that was our kind of mission. So we used the same UAV. Again, there are a lot of FAA regulations, so we had to have a ground pilot. Okay, so do you know how we shipped the UAV from West Virginia to California? It's long distance. We FedExed them because it's light enough, right? And then we just disassemble it, and in the field, assemble back. So that was actually how we did. And this is kind of the flight path that we took. So what we did was, okay, the UAV take off, and then it flies kind of serpentine patterns, and then landed down. Okay. Whenever actually this UAV flies, the camera is continuously taking pictures. Okay, so we'll have a series of images, right? That's what I'm going to say. So if it says GPS guided, so we have to have some safety things. So we have to program it whenever it goes out certain distance or certain landmark, crash or return back. That was kind of we programmed. Oh, here we go. So this we have to do in-field coordination, right? It should be very safe. So we made sure nobody's there in the field when we fly. Okay, we are testing. So these are our groups for UAV flight. And finally, it took off from the ground, right? And I'll show you a couple of shots. This is actually UAV in the air. Okay, so what you see here is, this is actually bottom. Can you see the small hole? That's where camera actually stick out. Okay, and it has a GPS and it has a the black box. Okay, here we go. So now actually it's flying over the canopy. Okay, it is not perfect the flight always because the wind blows. It is not always like balanced. Sometimes it goes like that way. So here we go. And this is a black box record. If you look at the black box record, okay, x-axis is time. Okay, this is a speed, so speed changes, right? And camera shutter, so we know what time, when the camera shutter was like pressed. And then we have altitude. So by having this information, we have GPS as well. So we can actually georeference each images. That's the point. Okay, so here we go. This is actually one area image taken by UAV. When it turns, it took the picture of the California vineyard. So this is California vineyard. You see mile by mile, there's so many grapevines. Who is going to sample this? Okay. This is an easy one. West Virginia has terrain, right? So we start from easy ones. Okay, so we did the image stitching to make a composite image, right? So basically, this one goes like this. Again, not always perfect, but perfect enough to detect something. So now actually we have a composite image. What we are going to do? Are we going to go section by section to see morning glory flowers? No, we are talking about 1 terabyte of images. We cannot do that. So we have to do image analysis. This is a kind of general image analysis. So this is one of the image from the vineyard. Okay, I'll show you one thing. Can you see the small dot here? The white dot? That's a letter size paper. So, okay. This is not zoomed in yet. But so here we go. What we did was we enhanced the image. Okay, the raw image is kind of blurry, so we enhanced the image. And now you see small like area. This is the area I'm gonna show in detail. And then what we did was we put a filter on it. So morning glory flower was red or purple in color. So to distinguish that color, we have to put opposite color, which is cyan or green, right? So here we go. I'll show you one. So A is the original image, the small box. Okay, B is we enhance the image. C, we put the filter on it. And then now D, we convert this filtered image to black and white. Red become a white. Background become a black. So now you see black and white. Oops, so which means all of these white dots are morning glory flowers, and background is not a morning glory flowers. These days, we can count these dots very easily using one software, right? We just click it, and they will count it, how many dots are. Okay, so that's how we did it. So there's so many details, but I'm going to skip it. So now, actually, we were able to see morning glories in vineyard in California in a short period of time by covering large areas, right? Can we see insects? As an entomologist, I'm very curious. So we did a small study in Friendship Hill and Pennsylvania. So we made a small, like a 1 meter by 1 meter bed. Okay, we put some plants and insects like this. We have some insect specimens. We just hide it. Okay, blind test. And then we flew and take a picture. This is about 50 meters above the ground. Okay, so now what you see is, can you see glove here? Those are glove. That's the size. And now actually, I'm talking about this area, right? 1 meter by 1 meter. If we zoom in, can we see the insects? What do you think? Okay, here we go. Now, so these are actually the butterfly. Butterfly is big enough, right? But my point here is many entomologists, maybe most of entomologists, may be able to say what the butterfly is, right? So, for example, these are actually the swallowtail butterflies, and this is a monarch, and this is a painted lady, and right. So what we found was the resolution we are talking about is actually less than an inch. So which means if you drop something less than an inch, which is kind of bigger than inches, which is a kind of big coins, you may be able to find it. Okay, oh, here we go. We have, this is a coffee plants. We mimicked the defoliation, this lip. We mimic the defoliation. Can you see the defoliation? So that's the resolution we are talking about. Okay, we did one more test. How detailed can we see then? So this was what we did. So we put some of this kind of the resolution chart on the ground, and we fly over, take a picture. It's about 20 meters above the ground. You see that the shadow of the airplane. Oops. Okay, this is what we see. Here we go. So this is the original image. Okay, this is you see so many dots here, is squares. Each one is 1 inch by 1 inch. So biggest one is, this one is a 7 inch by 7 inch. So 7 inch by 7 inch, 6 inch by 6 inch, 5 inch by 5 inch, 4 inch by 4 inch, 2 and 1 inch, something like that. So anyway, this is the image from the UAV. Okay, what you see here is 7 by 7 is so detailed. But if you look at 1 inch by 1 inch, there are some actually areas you cannot see very well. But again, this is the resolution we are talking about. Okay. So now we could detect everything, and then again, the challenge for insect pest management is not only detecting, right, and then like recommending what to do, and then actually do management, right? What I'm going to talk about is actually do management part. So here we go. So you heard of stink bugs? If you're in the east, if you live in the East Coast, you may see a lot of these stink bugs coming to your house, right? And this is called the brown marmoset stink bug. It's invasive stink bugs from Asia. Okay, and the good news is we have actually another stink bug. It's called the soldier bug. Soldier bug is not, it's a stink bug. They're stinky, okay? They're stinky, but they are predator, which means they're killing other insects. So quite different. So how to distinguish? Please look at the shoulder, it's spiny, and black dot at the tip of abdomen. So what this insect does is, again, they're predator. They are eating bad insects. Okay. And then this is native. Okay? And now look at this. This is how actually they hunt. They love caterpillars. They love gypsy moth. They love all of other caterpillars. And then again, in West Virginia, we have this species, but numbers are not high enough. So what we try to do is mass rear them and release them. Okay, that's kind of idea. Okay, here we go. So how to release these insects? About 10 years ago, my predecessor at West Virginia University gave me a folder. She was a forest entomologist and then taxonomist. And she showed me an article from China. They are bombing the insects to deliver to the target. So, wow, how about actually delivering this way? So this is actually the UAV, and this is actually our delivery system. We call it the bug cannon. So flip over. Okay, here we go. This is actually the soldier bug house. There's a small kind of carton. Okay, we put insects inside, and this is the door. So the door is closed. So insects are inside that small area. And then this is pressed air. So what we are going to do is when it goes up to the sky, the door is going to open and put the air pressure, and then they just release. Okay. So what we found was more than 60 psi blow all the soldier bugs out, and then we recovered. I'm an entomologist again. We recovered, and we looked at the effect of aerial delivery on soldier bugs by looking at their mortality or their behavior or their, the reproduction. There was no problem. So this was the easy part. Now actually we are moving to more important and more actually the challenging part. There is actually a weed called a mite a minute. This weed disperses 1 mile per minute. So they spread very quickly. What they do is they actually cover the plants and they block photosynthesis, and it can kill the trees sometimes, not every time, but sometimes. Okay, this is actually the vine of mite a minute weed. Once you have it, it's hard to get rid of them. Okay, the good news is if you look at the mite a minute, can you see small shot holes? So there are insects feeding these mite a minute weavers. Okay. What's the size? This is the size. So this is actually the penny, right? And we are talking about 2 insects here. We cannot drop this one like that, right? Wind blows and we cannot target it. So we have to have something to deliver. So we developed something, okay? to do that, because before that, again, can be autonomous. Find the weaver and drop the weaver and drop the weaver and return back. So that's the kind of idea. So we made a bug bomb, this case. So all the small insect goes to inside the straw, okay? And then what we do is we close it, and we are going to drop from the UAV. When this one hits the ground, it pops up, and insect come out, right? That's the kind of story. So these are actually our bug bombs. Okay, 5 of them. And then we did preliminary study. So my engineer goes up to the engineering building, right? And then dropping. And then dropped and pops up. Can you see the weaver? Okay, here we go. So tiny, again. If you don't hit the target, this insect may not be able to find the host, right? We cannot release from the air. We cannot do that. We have to target it because it's so tiny. So to drop this one from airplane, so we have to have something, right? Dispenser, right? It can hold. So we developed the dispenser. So basically, this one is a rolling, and this bomb drops because at the bottom has a hole. So we use the helicopter this time for the precision dropping. Okay, here we go. This is actually bomb dispenser. If you zoom in, can you see? This one is a rolling, and there's a hole, and each bomb is going to drop. We also used actually a rotor. This is a quad rotor. So here we go. It has actually bug bomb dispenser. So we did we did validation study in the field, and here we go. This is actually our quad, and dropping the bomb right here. Okay, the bomb dropped. We ran, recover all the insects, right? And to see if there is any effect of aerial delivery and this weaver. So we have to make sure that they have two antennae, right? And 6 legs, right? Very important. Okay, no problem. You know, the weaver is the insect has a very thick skin, so generally they're okay. We did the walking test. They should walk normally, right? And mating, very important, right? Right, so we looked at those. The most important thing is feeding. They have to be able to feed on the microminute width. So we did like an image analysis again. And then what we found was aerial delivery of weaver didn't hurt in terms of feeding, walking, mating, or the normal biology. So now actually our design concept never changed, right? Cheap, safe, easy to control, and then it can carry multiple sensors. So now we have actually 2 platforms. One is a rotor. We have like 8 wings. We call the octa rotor, and we have small airplanes. So it can cover large areas or detailed areas, right? Airplane crashes. My engineer told me that there are 2 types of UAVs. One already crashed, and the other one is going to crash. Right. So safety is very important. So this happened in California Vineyard. And do you know this is my colleague? And he's smiling. Do you know why he's smiling after UAV crash? This is styrofoam. We put it together and fly again. Okay. So from 2015, what we try to do is we try to apply this technology we have to various other agro-ecosystems. So if you have something in mind, please let me know. So this is my collaborator from California and West Virginia. And sometimes we fly during the winter because the winter, depending on pest, winter may be the right time to detect, right? And we had a problem with engine, so we jump start with the car. Okay, thanks for listening, and this is my funding sources so far.